Quiz 12.1-12.4. I was not planning on doing another video. I'm a little bummed by this. 100 people enter a contest. First prize is a lifetime supply of chewing gum. Second is a subscription to Car and Driver magazine. Third prize is a can of dip. Billy and Bobby and Tammy have each bought tickets. Find the probability that they each win a prize. So you have to think about the number of ways this can happen. And we could do this through combinations if we want. Actually, this would be permutations. We could do it that way if we wanted to, but you could have Billy, Bobby, and Tammy first, second, third. You could have Billy, Tammy, Bobby first, second, third. Or you could have Bobby, Billy, and Tammy. Because remember, this is Bobby, Billy. I probably should have used different letters. But there's three ways this can happen. I can be this way, or that way, or that way. So that's the gist. There's three ways that this can happen. Now, each of them end up being the same exact probability. Say that Billy gets first. Well, there's 100 and tickets sold, so his probability of winning is 100. And then Bobby gets second. I'm saying the word and. Most of y'all listen without, or you don't even have the subtitles on, or it's muted. But anyways, the denominator decreases because a ticket has been pulled, and there's only 1 second place prize. And finally, and then Tammy wins the can of dip. It seems appropriate. It's the South. I know women who dip. Anyways, there's one ticket. There's only 98 left to pull from. So, and each of these work the same way. They're all the same exact probability. They're all the same exact setup. So, we're just going to add that thing to itself 3 times. We got 1 over 100 times 1 over 99 times 1 over 98. And we have to add that thing to itself 3 times, or we just multiply it by 3, because it's the same thing as adding. And let's see if it can convert it to a fraction. And the way I did this, it couldn't do it, but the answer choice is there. Let's see what the first one is. 3 over 970/200. Same exact decimal. So choice A. I think about half the class missed that one. Seems like a lot of kids pick D. All right, a math teacher uses Delta Math to assign extra work. On recent tests, 48% of his students passed the test. 80% of his students also used Delta Math. 78% of the students who passed the test also used Delta Math. Find the probability that a student passed the test given they used Delta Math. So I am finding the probability of passing given Delta. That's going to be the probability of passing and using Delta Math divided by the probability of using Delta Math. All right, so 80% of the students use Delta Math. There's an 80 in the bottom. 78% of the students who passed the test also use Delta Math. This is the and one, so it's 78 and 80. And, you know, I know the answer choice is D here, but 78 out of 80 should be 0.975. So choice D. Easy peasy freebie, miss it and you will be judged. Which of the following cannot be a probability? A probability is a number stuck between 0 and 1. It cannot be negative and it cannot exceed 1. That one and that one. And I want to say about 10% of the student body missed that one, and I judged you. I don't think that highly of you. 4 or 5, and I think 6 really threw some of y'all for a... No, it wasn't these that were bad. It was some of the other ones. All right, assume A and B have overlap. So because A and B have overlap, and this was on your formula sheet, the probability of event A or B happening is the probability of event A plus the probability of event B minus the probability of events A and B. Of course, we have issues with notation. That means or. That means and. Okay. And then we just add, subtract. So we're going to do 0.4 plus 0.3, and then we're going to take away the 0.56. That would be the probability of A union with B. And anyways, we get 0.7 minus 0.56 is 0.14. Choice B. And number 5, which did not have a correct answer present, I gave you extra points if it did. And if you're taking the second version, the correct answer will be there. I generally don't make the same mistake twice. But since I have this formula here, the probability of event A given B is defined as the probability of events A and B sitting pretty over the probability of event B. So I know this piece is 5/6. We use substitution here, because you know we can. We've learned about substitution before. And let's see, what else do I know? I know that the probability of event B is 0.7, which I'm going to write as 7/10. You can write it as 0.7, doesn't matter. And I have no idea what that is. Now, the opposite of division has always been multiplication, so we're going to multiply both sides by 7/10. I mean, you can use a calculator if you want, I don't feel like it. But anyways, we get 7 times 5, which is 35 over 60. And those are both divisible by 5. That's going to be 7 over 12. All right. Assume you have a deck of 52 cards without replacement, which means you take a card out and you don't put it back. Find the probability of drawing a king, an ace, and another king in that order. So a king, an ace, and another king. So there are 4 kings in a deck of cards. And so your probability of getting the first card is 4 and 52. And then you draw an ace, and the word and means multiply. There are still 4 aces in the deck, but there's only 51 cards. And then you draw a king. Well, there's now 3 kings because you pulled 1, and there's only 50 cards because you've been pulling cards. And you just work that out. Anyways, you push some buttons on TI-84, whatever. You end up with choice C. Without replacement, what is the probability of drawing a red card and then a jack? So this is a conditional problem because of how this can happen. Because there's the big what if it was red? What if this was the red card? Now, that's the problem with probability, is you actually have to be a thinking creature. You have to think about possible outcomes. So here's the deal. You pick a red card, and it's not a jack, and then you pick a jack. Or you pick a red card, and it is a jack, and then you pick another jack. So that's kind of what's going on in this question behind the scenes, and that's the issue with probability, is that you have to figure out what's actually happening, and then you have to do the math. So the probability of picking a red card, there's 2 red suits in a deck of cards. And I'm going to look at this one here. The first condition is we have a half. Now, I pick 1 red card. I have picked 1 card, which means there are now 51 cards left in this deck. But I didn't pick a jack, so there's 4 jacks left. Then we have the word or, which means add, plus the other way around, I picked a red card and it happened to be a jack. So if the card I picked happened to be a jack, there's now only 3 jacks left, and there's still 51 cards. So, moving forward on this one, I'm going to push buttons on this one. We have half times 4 over 51 plus a half times 3 over 51. Back to a fraction. 7/102. All right, moving on to 8, we have a 2-way table. You had to do some math on this one, not a whole lot. I didn't actually bother to look and see if anybody had any issues with the table. We got 37 kids in the balcony. Let's see here, that one I know is 21, 77. Bad looking 77. And we got 31 and 31, which makes 62. 93 here. So 205 total. Seems like I saw one or two kids have something a little bit different than 205. So find the probability that you are an adult. Okay, so that's going to be that number right there. There are 112 out of 205 adults. And one thing that a lot of kids did is they wrote just 112. It's probability. Probability cannot exceed 1. And probability is always the number of desired outcomes over the total number of possible outcomes. All right. The next one is find the probability that you're an adult or a child. Well, that's going to be everybody. Everybody is either an adult or a child. That's 205 and 205. And I almost knocked off points if that's how you wrote your answer, but I just felt sorry for you. But that's 1. All right, part 3, find the probability that not a child and not a balcony. So when I do this one, what that means is I don't care about anybody who's in the balcony. Like, they're not on my mind. And I also don't care about anybody who's not a child. Oh, actually, I did that wrong. Sorry. Not a child and not balcony. Just had a funny moment there. Yeah, so I don't care. I'm tired, forgive me. I care about these two things. And I add them together. Take 36 and 39, you get 60, 75. Seems legit. So 75 and 205. And what's that reduce on down to? Those both divisible by 5, 13 and 43. There you go, 13 and 43. Find the probability that your child, given you're in the circle. So my attention is focused on the circle. The circle, see that divisor, is your divisor. There's 60 people in the circle. There are 39 children in the circle. And those are both divisible by number 3, I believe. 13 and 20. No, I did that wrong. There's 21 kids. I'm looking at the wrong number. 21 over 60, which is going to be 7 over 20. All right, moving forward, number 9. It's like I just got really tired. Consider the Venn diagram and answer the following questions. Find the probability of rock given wrap. So I'm going to focus on the wrap circle. And within that wrap circle, these people like rock. There's 18 people that like rock in the wrap circle. And the wrap circle's got 18, 19 people, and then 24, which is 43. 18 out of 43. We have the U there, which means or, that I like rock or I like wrap, one of the two. So I'm going to focus on all these numbers, but I'm only going to add them one time. So I have 18 and 11, which is 29, plus 8, which is 37, plus 7, which is 44, plus 1, which is 45. Looks like 69. Let me double check that. 25, 32, 40, 51, 69. Yeah, there's 69 people. And how many people are there total? That was something I think a lot of people missed. If you add in this other 17, there's 86 total people in there. And I don't believe that reduces. All right, the next one is rock and wrap. And the and is the overlap. I like rock and wrap. There's 18 of them. Those two guys right there are the overlap between rock and wrap. And they're 18 of 86, and that will reduce. That's going to be 9/43. All right, part 4. Country and not rock and not rap. So country and not rock and not rap. What that means is that I cannot highlight anything that's rock, I cannot highlight anything that's rap, but I have country. And there's 17 people out of 86, and that does not reduce. But yeah, these really threw kids for a loop on them. All right, classify the following events as independent, disjoint, overlapping, not mutually exclusive, conditional, or none of the above. So you're supposed to at least be able to look at the formulas that were given to you and figure out what to do. So this one gives me a couple of pieces, and memorization is really where it's at. If I could just get kids to finally understand that, I'd be golden. But if the probability of event A times the probability of event B is equal to the probability of A and B, I'm just going to use the N, then the events are independent. And that's how it works. If those things are true, the events are independent. So what I'm doing here is I'm saying is 0.3 times 0.2 equal to 0.06. And the number of kids I've watched push buttons on a calculator, and that tells me the issue. 0.3 times 0.2 is, by God, 0.06. So these events are independent of each other. All right. Now the next one I gave quite a bit of stuff, but I'm focusing on the given. So let's write out the given formula. Yeah, so if the probability of event A given B is equal to the probability of event A and B divided by the probability of event B, the events are conditional. All right, this is true. It's going to be our conditional probability problems. So we're going to plug in some numbers. The question is 2/5 equal to 1/10 divided by 1/4? Okay, so let's check this. We got 2/5 equal to, and I know you guys we kind of suck at this. Let's take 1/10. You divide it by 1/4. 1/4 of 10, by the way, being 2.5. That's how I do it. You get 4/10 as a fraction, 2/5. 2/5 equal to 2/5. These are conditional probabilities. So this one, I noticed, gave me a whole lot of stuff. It gave me the ors and the ands. It did. It gave me both. So if you would have looked at your answer documents, you have those formulas, but if the probability of events A or B happening is equal to the probability of event A plus the probability of event B minus the probability of A and B occurring, the events overlap. Okay? So you just plug in and see if it's true or not. So we have a 9/20 for A or B. Is it equal to 1/3 plus 2/5 minus 17/60? For no good reason, I'm going to do this old school. And turn that into a 60 and that into a 60. So this is going to be 20/60 plus 24/60 minus 17/60. 20 and 24 is 44. 44 minus 17, 27. So I get 27 over 60. So it was 9 and 20 equal to 27 over 60. It sure is, because these are both divisible by 3. So we got the pass. We have overlapping probabilities. All right, find 7, choose 4 by hand. So the formula for NCR is n factorial over n minus r factorial r factorial. These went well. There was probably only 5 or 6 kids that missed these, so they went well. We have a 7 factorial sitting pretty over 7 minus 4 factorial, 4 factorial. We write it out. We get 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 minus 4 is 3, so 3 factorial, 3 times 2 times 1, times 4 times 3 times 2 times 1. And then we do some cancellations. And I know that 3 times 2 is 6, so I'm going to get rid of that 6 too. And up top, I'm left with 7 times 5, which is 35. 35 ways to choose 4 things out of a group of 7 things, if order does not matter. All right, next up is the permutation. N pick R is n factorial over simply n minus r factorial. So there's 6 things, so 6 factorial over 6 minus 3 factorial. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 6 minus 3 is 3, 3 times 2 times 1, cancel, cancel. And we got 6 times 5, which is, I forgot that 3, 6 times 5, which is 30 times 4, which is 120. There are 120 ways to pick 3 things out of 6 if order matters. All right, here's your little political satire. The president's aide is laying out the president's schedule. He can sign 1 of 3 executive orders. He can impose tariffs on 1 of 7 different countries. He can threaten 1 of 5 different countries. He can golf at 1 of 2 different locations. And finally, he can make a phone call to either Vladimir Putin or Kim Jong-un. Those are the supposed president and dictator of Russia and Korea, North Korea, by the way. How many different ways can the aide lay out the president's schedule? This is called the fundamental counting principle. I should probably type this because I can't even write it. It's the fundamental counting principle. And the fundamental counting principle just basically says if one event can happen m ways and another event can happen n ways, then the total number of ways both events can happen, thank you, Micah, is m times n. So you just extend this thing as far as you need. This thing has lots of variables, but just focus on the numbers. 3, 7, 5, 2, and there's 2 people here. Right there, choice B. One of the easier questions on the test. I never went back and looked and saw how many got it right, how many got it wrong. At that point in time, I was just grading. Class officers are to be picked from a pool of 30 students. The officers are president, vice president, and secretary. These are rank positions, order matters. That means you're a permutation. So let's write down the formula for permutations, n pick r. It's n factorial over n minus r factorial. N is 30, 1, 2, 3, r is 3, okay? So we're looking for 30 factorial over 27 factorial because we're thinking about 30 factorial over 30 minus 3 factorial, choice D. 15, what would the complement of the event A be? If event A is a number, is a prime number between 0 through 10. I don't like the way I wrote that, but whatever. I'm a prime number between 0 and 10. So your primes from 0 to 10 are 2, 3, 5, 7. And I realize that a lot of kids don't know what a prime number is. 100% know that. That's your problem. Fix it. Anyways. So the complement of being a prime would simply be not being a prime. Choice B. It has nothing to do with being even or odd, and there's a reason I wrote those because a lot of kids think that, and I've done this for a long time, so I know what they're thinking. This right here is literally the definition of prime. Anyways, fix your issue with primes. I think 16, based on what I remember, was probably the most missed question on the whole quiz, and most of that is because you guys don't do your Venn diagrams right. So I'm going to focus on the last thing I'm told, which is that 9 are useless. I'm just going to put a 9 there. And the second last thing I was told is that 10 employees can run everything. There's a 10, and you start there and you work your way out. So anyways, 19 can run a mill and operate a punch press. So this territory right here is going to add to 19. And I already have 10. There's a 9. 24 can run a lathe and operate a press punch. So this territory right here is going to be 24. but 10 is accounted for. 27 can run the lathe and the milling machine. So 27 right here, 10's accounted for, 17. All right, now let's jump back to the top. 44 can run a lathe. So this whole circle's 44. But you've already got some people in there. And you need to take them out. You've accounted for 14 already, you've accounted for 10 already, and you've accounted for 17 already. There's 3 left. And it looks kind of weird, you know, because it seems like there's more circle there. It's just a visual approach. All right, how many people can run a press? Punch press is 56. So we're going to take away what we have. We have a 9 that's already in that circle. We have a 10 that's already in that circle. And we have this 14 that's already in that circle. 23 left. And finally, we have the milling machine. 49. It was 49. 49 minus 9 is 40, minus 10 is 30, minus 17 is hopefully 23. And there's my completed Venn diagram. The only thing I really need to know is how many people are in this entire thing. And that was messed up on a couple people, and I have a good idea of where you're going to mess up, so I probably have some numbers down here that you would have gotten had you messed up. So I see a 9. I'm going to double check my circles real quick. Punch. It's 56, 23, 33, 42, 56. The mill is 49, 19, 40, 19. Oh, see, I've done something wrong in the mill. The mill is supposed to be 49, isn't it? I caught a mistake. Anyways, where was I? I got to figure out how many people are in this thing. Only add things once. 3 and 9 are the last 2 to go. 98. Now, once you figure out that things have a 98, you should probably be kind of like looking at the things that have 98s in them. And maybe half of that, which is 49. But just knowing how many people are in this diagram has made most of these questions pretty redundant. There are 9 useless employees in 98. Useless or punch. Okay, so useless or punch. I'm going to be adding those guys and all of those guys because they are useless or in the punch circle. The punch circle on its own was 56, and 56 plus 9 is 65. So choice B. Lathe given mill. Now this is where it gets difficult for a lot of kids. Lathe given mill. Here's your mill circle. And the mill circle had 49 people in it. So I'm actually looking for a denominator of 49. And that's going to be the answer because if you take 10 and 17 and put them together, you get 27. All right, the probability of not operating a lathe. That means you can do everything else or absolutely nothing. Not in the lathe, not in the lathe, not in the lathe, not in the lathe. Everything else was in the lathe. So, and the reality is there's other ways of doing this one. "44 employees can run a lathe." If you just do 98 minus 44, you'll have your answer. That's 54. 54 of 98. All right, moving forward. Last 2. All right, how many different arrangements are there for the word Mississippi? Mississippi's got 4, 7, 10, 11 letters, so 11 factorial. And then we're going to focus on the repeats. There's 1, 2, 3, 4 I's, 4 factorials, 1, 2, 3, 4 S's, 4 factorial, and then 2 P's, 2 factorial. We don't worry about something that doesn't repeat because 1 factorial is 1. We only worry about things that repeat. And then we get to push some buttons on a calculator. I feel like the answer is A, but I don't remember. 11 math, probability, factorial, divided by parentheses 4 math, probability, factorial, 2 math, probability, factorial, 2 math, probability, factorial. I was wrong. It's 415,800, which is not right because I made a typo. Right there. There we go. Choice A. All right, 18. 3 marbles are to be drawn at random without replacement from a bag containing 10 red marbles, 10 blue marbles, and 5 white marbles. So first thing is there's 25 marbles. All right, that's part of it. What's the probability of drawing 2 whites and 1 blue? So think about how this could happen. You could have white, white, blue, or you could have white, blue, white, or blue, white, white. Every time I see the word or, that means I do add, okay? That's what that means. Now, these fractions, while not in the same order, will all be the same thing. Probability of drawing a white marble is originally 5 and 25. Then you've pulled one, so now it's 4 and 24. And now you're at blue, and there are 10 blue marbles, 10 and 23. On the next one, white is still going to be 5 and 25. Blue is 10 out of 24 marbles. And the next one is going to be 4 in 23 marbles. And then the last way this could happen would be blue, white, white. So it kind of starts off with a 10 and 25. And then we have 5 blue marbles, but only 24 left in the bag. And then we have 4 whites, but only 23 left in the bag. So these things don't look the same, but they are. And I know you don't believe me because your number sense is atrocious. But I don't feel like writing all that in a calculator. So you're just going to have to trust me on that. Anyways, multiply it by 3 because there's 3 events that are the same. Probability of happening. Back to a fraction. And you get choice A, 1 in 23. And that was your test. This will probably have about 3 whole views. Crazy. Let kids fix anything. Nobody fixes anything.